Hello, my fellow technology peers and Dr. Colin. My name is Sierra Houston, and I'm going to present my poster on crop ecology and nutritional variability influence growth and secondary metabolites of Stevia rhambonia brittonii. Stevia is a perennial herb of the Asteraceae family and is native to South America. It is globally grown for its diterpenoids. The diterpenoids, stevioglycide, are non-sucrose, and they also have no calories for a sweetener. And this is why it makes it so popular. In stevia, the glycosides are mainly accumulated within its leaves, followed by the stems, then the seeds, and then the roots. The most abundant glycoside in the stevia leaf is stevioside, and then followed by ribonoside. There is a research relating to the leaf biomass and the concentration of glycosides, depending on the growing conditions and the agronomical practices. So in this experiment or in this field study, it's conducted in northern India and is testing the concentration of glycosides in the leaf biomass. So the study is, this field experiment is done using 3 different levels of nitrogen, 2 different levels of phosphorus, and 3 different levels of potassium at 3 different locations. During this experiment, we're going to be looking for the nutritional variability and the secondary metabolites of stevia by looking at the leaf yield. So investigations were carried out during 2010 and 2011 growing seasons at all 3 of the locations for the field sites. The first site of the experimental farm was an experimental farm, SCIR, Institute of Himalayan Biosource Biotechnology, CSIR, IHBT, sorry for the acronym. And the second location was at a regional horticultural research station, and the acronym is RHRS. And the last testing site was agronomy research farm in Punjab Agricultural University with the acronym PAU. For these methods, the stevia seedlings were transplanted with 45 plants in each plot. A half quantity of nitrogen and a full quantity of phosphorus and potassium were both added at the per treatment when they're applied at the time of transplanting. And so this graph just shows the different levels of the potassium and the phosphorus and the nitrogen at those different times. You can see 30, 60, and 90. And then, yeah, I'll go back to that graph in a second, sorry. The remaining half of the nitrogen was applied and split up into 2 equal doses and applied 60 and 30 days after transplanting. To look at the growth for this, the plants were randomly selected from the center of each plot and then cut at 15 centimeters height from the ground level. At the first harvest, the plants from the first harvest were then marked with an aluminum tag for the next observation, which would be the second harvest. During the second harvest, the roots were removed from 0 to 25 centimeters of soil. And this was done so you can test for nitrogen and phosphorus and potassium. After the removal of the plants from the field, leaves were then separated for the stem, and total number of branches, both primary and secondary, were counted per plant. So if you see the total number of branches, that's what that is including. The total number, or the total area of fresh leaves under respective treatments were then measured using a leaf area meter. So if you see the LAI, which is the leaf area index, These are the numbers, so these are the data that you're getting from the leaf area index. The estimation of stevioglycosides in the leaves were harvested in the middle of the section from the plant at all 3 locations. So at all 3 locations, they took the leaves and harvested the middle section to test for the glycosides. End result showed that the accumulation of steviosides is controlled by the climate conditions and nutritional management. The 2 major stevioside glycosides are in the leaf. Stevicide and Reba A had both a noticeable difference in all 3 locations. The treatment recorded about 17% higher. Recorded about 18% higher in stevioside content in the leaf compared with nitrogen. Compared with the nitrogen treatment, and this is then compared to the phosphorus and potassium. So the nitrogen overall had a higher result in leaf area index, and this resulted in stevioside content being higher. In the study, the dry leaf yield of stevioside was increased by the nitrogen levels at all 3 locations. And that's just to summarize what I said. The dry leaf yield, the number of branches and the leaf index are the 2 main attributes of stevia, shown that the plant were significantly affected by the levels of nitrogen, particularly in the first harvest during both years. I used table 2 in order to show the results of the nitrogen increase, and this will show both in leaf area index and the total number of branches. The specific leaf weight, there wasn't a noticeable difference, but it's still included in table 2. These results are due to the higher doses of nitrogen, increasing the availability of nitrogen in the soil, and this will induce cytokinesis in the root tips and will maintain a desirable cytokine to auxin ratio. The maximum leaf yield was obtained with higher doses of nitrogen. So yeah, no numbers were significantly different, but you can see for the nitrogen, the more it is increased, the bigger your leaf area index is compared to the levels of phosphorus and potassium used in this experiment. So yeah, that was my poster. I have my references down here if you guys want to check out the article itself. I would say that the graphs used are very hard to see. So this is why I did include table 2, because it is a little bit easier to see. I hope you guys enjoyed, and good luck on finals.